Look at this massive automated shipping port operating at peak capacity. It's easy to view logistics as a series of impressive, distinct physical operations. Today, we move beyond localized nodes to view the supply chain as one holistic value stream. The standard approach to managing these networks relies heavily on isolated functions. Each department tries to maximize its own efficiency metrics, which often inadvertently degrades the performance of the overall system. A procurement team might secure an exceptionally cheap supplier for raw materials to hit their cost-saving targets. But if that supplier consistently misses delivery windows, the production line stalls and the final product reaches the customer late. The primary purpose of an end-to-end or E-to-E architecture is to explicitly eliminate this suboptimization. It forces the organization to prioritize the total cost to serve over the isolated costs of any single department. Removing these functional silos smooths out daily operations and removes friction in communication. This significantly improves the system's overall resilience and the speed of decision-making when dealing with market uncertainty. Ultimately, an end-to-end framework ensures that every operation, from a forklift movement to an overseas freight contract, is perfectly aligned with the overarching business strategy, rather than individual department targets. This flowchart maps an end-to-end supply chain, managing activities from customer demand to after-sales. When optimizing, the question is, from where to where? We trace backward from the customer signal, through production to raw materials, then forward, extending through final delivery and returns. Standard logistics focuses on managing the movement of goods between specific physical points. The end-to-end framework, however, treats every single step in that chain as one continuous, integrated system. This means zero functional silos. Every tactical decision is calculated based entirely on its total system impact. This diagram outlines an end-to-end system. Operations break into plan, source, make, deliver, and return, wrapped in enable. Plan, source, and make handle forecasting, sourcing, and production. Deliver and return handle fulfillment and reverse logistics. Finally, enable ensures uniform data integration blankets these blocks. In practice, this architecture enables demand-driven planning. Instead of pushing forecasted inventory into warehouses, actual customer sales data serves as the direct trigger for upstream procurement. This requires integrated sales and operations planning. The sales teams, the finance departments, and supply planners can no longer maintain isolated spreadsheets. They must operate from one rigorously updated, shared plan. Maintaining this unified plan requires real-time data visibility across the entire network, tracking material flow from supplier capacity through the factory, into the warehouse, and out to customers. Operating these components as a singular value stream ensures that critical market data flows freely, preventing the information blockages that typically plague segmented departments. Looking at this 2x2 matrix, we see the characteristics required to govern an end-to-end network. The first requirement is absolute customer centricity. The entire chain is engineered backward from the actual demand, rather than forward from factory outputs. Next is cross-functional governance. Instead of traditional departmental leadership, where a VP of logistics only oversees trucking, leaders are accountable for the outcomes of processes that span multiple departments. That governance is enforced through shared metrics. Rather than measuring a warehouse solely on storage costs, the entire network is evaluated on universal metrics like on-time and full delivery rates. This shifts the organizational focus toward total system flow. Maximizing the uptime of a single machine is counterproductive if it simply builds up excess inventory at the next choke point in the chain. Operating this way requires strict trade-off management. Decision-makers must constantly balance operational costs against desired service levels and their exposure to supply chain risk. These trade-offs are managed through the principle of pull over push. Actual, verified demand signals directly trigger the movement of supply, rather than producing goods on speculation and pushing them out. Without enforcing those shared metrics and a strict pull philosophy, any network will inevitably degrade back into siloed, localized behavior. This architecture is a strict requirement in consumer goods sectors, where demand-driven replenishment ensures supermarket shelves stay perfectly stocked without holding costly backroom inventories. Furthermore, maintaining this level of visibility is the primary tool for disruption management. During global events like pandemics or sudden material shortages, an integrated system can trace the exact location of critical inventory and reroute it immediately. This myth versus reality table breaks down the common misunderstandings that cause end-to-end transformations to fail in practice. The first misconception is that end-to-end simply means documenting and mapping existing processes. In reality, it requires establishing integrated decision-making protocols and strict cross-functional accountability. The second major error is assuming that purchasing an enterprise IT system automatically creates an integrated supply chain. Systems are necessary enablers, but they do not structure the business. The third point is the trap of siloed KPIs. You cannot maintain a high-functioning system if manufacturing is rewarded for overproduction while warehousing is penalized for high storage costs. The outcomes must be shared. Process mapping and software platforms provide the infrastructure, but it is exclusively cross-functional leadership and strict governance that actually create an end-to-end reality. This summary slide delineates the 3 tiers of supply chain evolution. We can see the progression from traditional to integrated and finally to end-to-end. The traditional supply chain operates almost entirely on function-based metrics, leaving it highly siloed and prone to bottlenecks. An integrated supply chain successfully connects those functions with shared software and data, but it still lacks total holistic governance over the final outcomes. A true end-to-end system achieves all 3. It is fully connected, strictly governed across functions, and mathematically optimized as a single, unified system. As you evaluate your own operations, consider this. Where does your specific supply chain actually start, and where does it truly end? And more importantly, if customer demand drops unexpectedly tomorrow morning, exactly how fast can your entire interconnected chain adjust its upstream behavior? Achieving true end-to-end integration is a defensive strategy for maintaining profitability and service against continuous global uncertainty.